Okay, this is a polar problem. They are giving you the equation of r, and they actually tell you that we're looking at this graph from 0 to pi, and you do have a calculator. So part A is asking you to find the area of this curve, and if you look at this curve on the calculator and you type in the bounds as theta equals 0 and theta equals pi, you will notice that's how long it takes for this entire curve to graph. So area of a polar is just 1/2 r squared d theta. So 1/2 r is given, squared d theta. The bounds are going to be from 0 to pi. Punch that on your calculator. You should get 4.38231. Part B. Find the angle that corresponds to the point on the curve with x coordinate of -2. So they want you to come up with what is the angle where x is equal to -2. So the only equation that has x and theta in it, which is what we're looking for, is your conversion equation, x equals r cosine theta. They tell you that x is -2, r is the original equation which is given, so do that substitution, and then cosine theta. Use your calculator, and again you can be in your functions mode. So y1, y2, call this x instead of theta, it's just a variable. And from your calculator, you should get theta equals 2.78606. Okay, part C. For pi thirds to 2 pi thirds, dr d theta is negative. What does this say about r? What does this say about the curve? So they want you to explain what this means. Just explain it in terms of what you see here. This is just slope, but it's talking about the slope of r. What happens to r as theta increases? So this just means as theta increases, r decreases. Or you could also go the other direction. But when we think about a polar curve, we're graphing it out as theta increases this way. Now, what does this really say about the curve? So think about as theta increases, r is decreasing. What does the r represent on your polar curve? It represents really your distance from 0, right? Think about your polar curve and what your polar curve looks like. And this has come up before, so your r is really the distance from 0. So it's saying that this curve, as theta increases, the curve is getting closer to 0 or the origin. Okay. Part D. Find the value of theta only on this interval that corresponds to the point on the curve in the first quadrant, that's why they gave you this interval, with the greatest distance from the origin. So again, if you understood what part C was, the distance from the origin is r. R represents the distance from the origin. If I tell you r is equal to 3, you just count out 3 units. So really what they're asking for is the greatest distance from the origin, which is r, so the greatest is going to be the maximum of r. So they want you to find the maximum value of r. Okay, anytime you see those words, maximum of whatever function you're talking about, you need the derivative. You need the derivative of r. They tell you r is this. I need the derivative of that, which is dr d theta, and they actually give you that as well, which is 1 plus 2 cosine 2 theta. My critical numbers are set this equal to 0. It ends up that -1/2 is cosine of 2 theta. You do have a calculator. You can solve this by hand, or theta ends up being pi thirds. So that's your critical number, but I want the absolute max. When they don't put relative, it implies absolute, so I also need to check endpoints. So my endpoints are 0 and pi halves. So these are my 3 possibilities. So I'm going to check my possibilities, 0, pi thirds, and pi halves. And what am I trying to maximize? R. So I'm going to take these, plug it back into your R value, and use your calculator to punch this out. The biggest number that I get is, that's your maximum R, and it happens when theta equals pi thirds. So the greatest distance from the origin, which is probably somewhere over here, is pi thirds.